In this video, we will discuss random variables and probability distributions. Let's take a look at our first example. Suppose there are 3 lollipops and 5 chocolates in your kitchen drawer. You decide to randomly select 3 and observe the number of lollipops that you draw. Part A. Define the random variable x. So if you were to do this theoretical experiment, what would be your random variable? Remember, our random variables are what we are interested in recording. And those have to be numerical outcomes. So this says that we observe the number of lollipops that we draw. So that means that x is going to be the number of lollipops observed or drawn. Okay, if that's what our random variable is, what values can x be? So, in other words, what different numbers of lollipops could we draw? Now remember, our situation says we decide to randomly select 3. So we're drawing a group of 3 from our drawer and we are counting our random variable x, the number of lollipops there are. So what could x be? So we draw 3, we could get no lollipops, we could get 1 lollipop, we could get 2, or we could, pretty small chance, pick all 3 lollipops out of the 8. So this is starting to create a probability distribution. Now, if we were to actually do this experiment and calculate all the probabilities, that would be quite a bit of work, but it could end up looking something like this, where we record our results in a table. Here are the values that x can take on, and then here are their associated probabilities. So let's try the next example. Suppose the random variable x has the following probability distribution. Find the following probabilities. What is the probability that x is less than or equal to 2? So using that table, we want to look and see where are the values that are where x is less than or equal to 2. Okay, less than or equal to. So it can be 2 or it can be smaller. So that would be these. And then the associated probabilities, because we want the probability, would be those 3. So it would be 0.3 plus 0.2 plus 0.1, which gives us 0.6. Okay, next we want the probability that x is equal to 0. So in this case, we're not looking for more than one value. We're looking for simply this one line where x is 0. And that gives us a probability of 0.2. Okay, next we want what is the probability that x is greater than 0? So strictly larger than 0, not equal to it. So here are all the values where x is larger than 0, 2, 4, and 8. And the associated probabilities are 0.3 plus 0.3 plus 0.1. So we get 0.7 is the probability that x is greater than 0. And that's how you use a probability distribution to calculate probabilities.